at 7:30 we've got a declination of south 8 7.8, and of course we need to apply the D correction to that as well for 30 minutes. So our D value is 0.9, and you can see that between 7 and 8 o'clock that declination is increasing. So whatever my D correction is, I'm going to be adding that on to give me the 7:30 value. In the increments tables, 0.9 at 30 minutes gives me a D correction of 0.5, so I'm going to add 0.5 on here. To give me south 8 degrees 8.3 as my overall declination. Okay, you'll need your formula sheets for this next part. Because what your formula sheets will tell you is that to find the sine of the amplitude, you need to divide the sine of the declination by the cosine of the latitude. The declination is obviously what we've just retrieved from the almanac, and the latitude is given as a dr in the question. Once we've found the sine of the amplitude, simply hit shift, sine to the -1, answer, will give you an amplitude of 8.389, etc. So we're going to call that 8.4, and we have to name this, and the naming convention for this is going to be after the declination for the north-south component. So this one's going to be south, and it's named east or west depending on whether the body is rising or setting. Now for the sun at sunrise, the sun rises in the east, so we're going to call this one east south. East 8.4 south. To find a true bearing from this, yes?
You know when you're naming the amplitude, do you have to put east on the bar, south or east or southeast?
You can do either actually. However, when it comes to converting into true, putting east and then the value and then south reminds you that you're going to be applying this value to 90 or 270 rather than 360 or 180 as you would for an azimuth. It's a good practice to get into, I would say. Strictly speaking, you should put it like this. So in this case we've got an east-south. I'm going to start in that case from 90 degrees, 090, because that's my east, but it's going to be to the south of that. So how might I find my true bearing here?
Add it to... Right.
Excellent, you
90,
would add it to
yeah.
90, yeah. So 90 plus 8.4 will give me a true bearing of 098.4 degrees true. Armed with that information, I can then go about doing a conventional compass error. The question asks for a magnetic compass error and the deviation. So I'm going to use the TVMDC format here for working it out. You can always do it the other way if you prefer. But I'm going to put the true in here. And bearing in mind that when we go from true to compass, anything that's east gets subtracted and anything that's west gets added. The opposite of when you go from compass to true and you add east and subtract west. So make sure you don't get those confused. True to compass, you're going to be subtracting east and adding west. So 098.4, minus 2 degrees east gives me 096.4. And then I have to work out what I would need to get from 096.4 to 098.0. In this case, we can tell that that would have to be an addition. So I know for one thing that my deviation is going to be west here, because it would need to be added on. And the gap between 96.4 and 98 is actually bridged by adding 1.6. So my deviation is 1.6 west. And overall, my compass error is that difference between true and compass. And the difference is 0.4. And the true is greater than the compass error, so the error has to be east. Error east, compass least. And you can confirm that actually looking at the deviation and the variation, that 2 degrees east, 1.6 degrees west gives you 0.4 east at the end, left over. So our compass error is 0.4 degrees east. And that gets you all the information that's asked for in question 1.